Hello, everyone. My name is Filip Jankovic. I'm a software engineer and an engineering manager at AMD. With me today is Slobodan Josic from our team. We're working together on AMD's ROCm Radeon initiative, which is really about making Radeon a great platform for AI development and local inference. So today we'll talk about, start by talking a little bit about ROCm as a platform. We'll talk about specific Radeon use cases, and then Slobodan, the more interesting part of the presentation, he will show you some practical use cases and it's not a live demo, unfortunately, but it's a recorded demo, and for a live demo, you can visit our booth in the hall. So let's start. For those of you who don't know, ROCm is AMD's open compute platform for accelerating AI workloads. It's really the world's leading open source AI platform. It supports all of our GPUs, including Datacenter, Instinct series, and Radeon consumer products. So it's really a mature ecosystem, and it has made a tremendous amount of progress in the last couple of years. And that progress is accelerating still, and it's trusted by our customers and partners and actively used for really cutting edge and frontier models, training and inference. Like I said, it's used by OpenAI, it's used by xAI, Meta, and many, many other customers of ours. So this is what it looks like. As part of the ROCm software stack, we provide the runtimes, compilers, tools, libraries, and it all integrates into most popular ML frameworks such as PyTorch, Onyx Runtime, JAX, etc. Really the point of the ROCm stack is to allow you to work at your preferred level of abstraction. If you want, you can use our HIP programming language to write GPU kernels. It's fully compatible with CUDA, and you can easily port your CUDA code, if you have existing CUDA codes, to HIP by using our Hipify tool, or you can just write your own HIP kernels directly. And you can also use some of the implementations available in the libraries, which are part of ROCm. Most interestingly, perhaps, are the math libraries, and I would like to highlight HibLasLT. That's our high-performance ML BLAST library, so it provides solutions for linear algebra problems, GEMS, and other kernels. Yeah, worth mentioning is also MIOpen, which is our provides convolution implementations, and composable kernels has many other kernels. And then our MGraphics is our graph optimizer, and there are many other libraries that you can take a look at. There's also other tools such as RCCL, which is very cool, enables multi-GPU training and inference, and tools such as ROCgdb, which is our debugger, and ROCprof, and other profiling tools which enable you to really make sure that your application is performant and that it works well. And what you're most likely actually to use are all these frameworks, but if you use them on an AMD GPU, they will use ROCm in the background. So by using PyTorch or any of these frameworks, it will use ROCm to ensure the best performance. So really, our ROCm is not just a software stack, it's a whole ecosystem, and like I said, a mature one. We have day zero support for all the cutting edge models. When DeepSeek came out, it worked right away on our Instinct and Radeon products. So I already mentioned all these popular frameworks, and we're very committed to making sure that these frameworks work well on ROCm and on Radeon. So we're ensuring that for each ROCm release, there is extensive QA coverage and other processes within AMD to make sure that we don't break those frameworks. And vice versa, in these frameworks, there is a lot of work from our side to ensure that there is the CI checks on ROCm. So one good example is PyTorch. When you submit a PR to PyTorch, it has to go through a CI check on ROCm to get merged. So that ensures that PyTorch main stays stable on ROCm. And we're doing that with many, many frameworks, and we're increasing our CI coverage. Another thing worth mentioning is Triton. Triton is OpenAI's GPU programming language and compiler. So it's kind of Python-like GPU programming language is getting more popular. It has ROCm support. So the compiler, generates performance code for AMD GPUs, and it's getting more and more traction in frameworks such as PyTorch and others. Already mentioned VLLM, Llama.cpp. Those are some very popular frameworks and inference engines. They are fully supported on Radeon GPUs, on ROCm, and very performant and very good option if you want to run local inference. So some updates from us from this year. We've added support for our latest Radeon products, such as our APUs, Ryzen AI Max series, and the Radeon RDNA 4-based GPUs which came out, which are the 9070 XT and the Pro series R9700. Then on the Linux side, we are working with the distros to provide what is called inbox support. That means that your favorite distro will come with ROCm support by default. And for the first time this year in September, we delivered PyTorch on ROCm on Windows. That is based on ROCm 6.4. It enabled, for the first time, to work in PyTorch natively on Windows. Previously, there was WSL support, but now we have native support. And that's being supported through ROCm 7, 7.1, etc. Onyx Runtime, it's a framework maintained by Microsoft, and we are providing an execution provider, which is very performant and supports fully Microsoft's Windows ML, which is Microsoft's new API launched recently, and it's their preferred solution for inference on Windows. So all this shows that ROCm is really an ecosystem built for scale. Apart from supporting Instinct platform, it supports Radeon, and you can, depending on the size of the model and your use case, you may choose to use one or the other. So for Radeon discrete GPUs, the common use case is the multi-GPU scenario where you have 2, 4, up to 8 GPUs, which then gives you a lot of memory to work with, and you can run medium-sized or even large models. And on the APU side, our Ryzen AI Max series has a lot of, our integrated GPU has, at a very low cost, provides a lot of VRAM and enables you to run models locally. So these are the two, I'll focus on the two main products that we have right now, our flagships. So this is the R9700 Radeon AI Pro, our flagship workstation AI GPU. So it's based on RDNA 4 architecture, and compared to RDNA 3, provides more performant compute cores and adds FP8 data type support. It has it's kind of a similar architecture to 9070 XT, but it has double the amount of VRAM. So it comes with 32 gigabytes of VRAM and allows you to run models on a single GPU and on multi-GPUs. On the APU side, our flagship launch this year also is Ryzen AI Max Plus 3985, also known as codename Strix Halo. And this is something that we're very proud of. It's a very powerful CPU, very powerful integrated GPU, and an NPU. Here I'm going to focus on the GPU side, and the AMD Radeon integrated graphics is fully supported in ROCm and has received a lot of optimizations on Linux and Windows. And you can use up to 96 gigabytes of VRAM. So it comes with, if you have 128 gigabytes of system RAM, this integrated GPU can access 96 gigabytes, which is at a very accessible price point. So it has really become very popular in the community and is serving as a great platform for AI development and for local inference. So, and that platform is actually what we're showing at the booth. Like, there is a live demo there, and what Slobodan is also showing is based on, everything is running on Strix Halo. So it's a great product. So before we move on to Slobodan, I have one more thing that I want to talk about, and it's a very important thing for us, and that's our commitment to the open source community, and that's best demonstrated by the ROC initiative, which launched this year. And it's really like a hub for the ROCm ecosystem in the open source community. It's a new ROCm build system. We rethink the way we work. We're no longer just developing internally and then open sourcing stuff. We are actively developing in the open, and the ROC enables you to build stuff very easily. Like, anyone can just go to the ROC, clone this repo, and build all the ROCm components from source, either on Linux or on Windows, very easily. And you can also just download the nightlies. So there are nightly builds available for Linux and Windows, like tarballs you can download and try out. And you're really at the bleeding edge of our development from our mainline branches. Not just that, like you can also contribute. We welcome community contributions, and you can also report any issues that you have, because those issues will be addressed. They are actively monitored. We have teams at AMD which monitor those issues and address them, communicate with our community, because we want to make sure that you, the users of our software, have, to solve your problems, actually. So I really encourage you to, take a look at the ROC and in general ROCm, and if you know how to contribute, go ahead and contribute. If you like doing that, I welcome you to apply for one of our open positions at careers.amd.com. We have positions in Serbia, working on this stuff and on other stuff, and also in other countries. Just take a look at their page, or at our page. Yeah, that's what I had, so I'll give it to Slobodan.
Thank you, Filip. So as Filip already mentioned, PyTorch is finally on Windows. So before September this year, when we are talking about AMD hardware, we had support only on Linux. But during previous 2 years, we worked hardly on enabling PyTorch on Windows. And in the meantime, we optimized a lot of backend libraries and features to work better on Linux also. So starting from September and with ROCm 6.4.4, we have PyTorch 2.8 on Windows working. And you can use that PyTorch on Windows on different RDNA 3, RDNA 4 architectures, and also on this Strix Halo that we mentioned. So PyTorch is supported on both Linux and Windows, and you can use it for very popular Gen AI use cases. For example, for LLMs, you can use a Python package called transformers, and for stable diffusion, so for text-to-image generation, you can use diffusers package or ConfUI, which is very popular framework in this area of text-to-image or text-to-video generation. Image on the right on this slide is generated on Strix Halo on Windows using that preview release that we added in September. This will be like a quick demo how you can use ConfUI on your local machine. So it's Filip already mentioned the ROC. So on the ROC GitHub repo, you can download every day like nightly builds and nightly PyTorch wheels. So it's enough to download these wheels and install them inside of some Python virtual environment and clone ConfUI repository and just run the whole application. Application is web UI based, so you have like view on the whole pipeline that will be executed. For example, you can on the left side go to templates and choose one of the popular stable diffusion or flux models. When you choose one of them, the whole pipeline will be loaded automatically. So in this example, we choose Flux Dev FP8 version, and all parameters are preset for you. You can choose prompt and type prompt that you want. You can specify number of steps, but this network is able to generate good images in only 4 denoising steps. You can see that GPU activity is going up to 100%, and everything is running locally on this strict scale. For the first run, we need to load all the models in GPU RAM. So the first run will be a little bit slower, but every next run, when you have all models loaded, and execution is faster. So based on the prompt, a highly detailed image will be generated. So this is one example of used prompt. And you can find a lot of interesting prompts already on the internet, or you can create your own one. Another very important use case in this area of generative AI is text generation. So instead of using web-based solutions and instead of using ChatGPT, you can have your local LLM running on your system, and that is very important if you have some important data that you don't want to share it outside of your organization. And for example, Strix Hello, because of the big VRAM, it's able to load really huge models. For example, this OpenAI GPT OSS 120 billion model, it can load it and execute very fast on your system. So we have our nightly builds, which combine llama.cpp with nightly the ROC builds. So you can easily download, package, extract binaries, and execute a model that you want on your machine. So this demo shows exactly that. So we just download zip package, extract it, and just run llama server locally with some predefined model. And this model will be loaded and run locally without internet access. So everything you want to ask your model will stay locally. For example, this is like a new web UI which llama.cpp folks added. So if we ask what is AMD, it will provide detailed information about our company. And it's running pretty fast, so it's generating around 60 tokens per second. Last but not least, use case is something called Amuse in combination with AMD GPU execution provider. It's Onyx runtime based, so Microsoft Onyx runtime inference engine used in the background different execution providers. Every hardware vendor should add its own execution provider. So we worked on enabling our GPU execution provider. We added support for RDNA 3, RDNA 4, discrete GPUs, and APUs like Strix Point and Strix Halo. This Amuse app has been developed in collaboration between AMD and TensorStack company. There are a lot of optimized stable diffusion and flux models available through this application. So you can download them, and in the background, what is happening? So application is using Onyx runtime, which is calling our AMD GPU execution provider, and already mentioned libraries, math libraries, and ROCm libraries such as MIGraphX, MIOpen, composable kernels. They are used to do this hard work, all compute work in the background. And because this is like a standalone application, you can easily start it. As I mentioned, there are some pre-optimized models which you can access through this model manager tab. You choose one of them, download, and install them. So they will be locally stored on your machine. You just need to load one of them, define your prompt, and just start generate and wait. So one note, just to note, for the first run, similar to PyTorch and ConfUI, here we also need to wait some time to load, because these models are really huge, tens of gigabytes each, and this Stable Diffusion has several models for text token generation, later for denoising step, decoding from latent space to visible image. So first inference time will be bigger, but once when we have everything loaded and pre-optimized, every next step, every next run will be much faster. And for example, for this concrete model, in 8 steps, network is able to generate interesting images. Everything is based on your prompt. And for the next run, as I said, you are not waiting anymore for pre-compiling, optimizing. Everything is already on your device. And there are several models that you can try. So everything is open source. You can download and try it on your devices. That's it. Thank you.
Thank you.
Okay, we have one question for now. In respect to small local inference work on personal machines, considering the non-insignificant performance overhead of Windows, especially 10 and 11, what was the idea behind even attempting to bring ROCm to work natively on it? Who could be an example of a target customer?
Okay, so yeah, I wouldn't say that necessarily Windows has an inherent overhead compared to Linux. I mean, we know that Linux is the premier AI development platform, and especially in the data center space. But really, if you look at the market share and laptops and desktops, and all the companies use Windows, so we need ROCm on Windows to, if you want to deploy your application, you will probably need Windows support. And also, some people like to develop directly on Windows, so we're providing that as an option where, there's still Linux and Windows, so more choice is better.
Yeah, if I can add, just like most of the gamers are on Windows, so if they are buying our gaming GPUs, they had also chance to experiment with AI models. So we are developing our hardware for gaming, but also with a big focus on AI capabilities.
So what would be the priority now? What would you say, gaming or AI, considering everything that is happening?
So, both are priorities.
Before AI gets big into the gaming. So then it will be the same thing.
Yeah, because it's already present in a lot of games. AI features for...
But what is more challenging?
AI for sure, because every day we are getting new models and we need to tackle new architecture problems and find bottlenecks in these architectures and optimize them to run better on our hardware.
Any questions from the hall? It's the first hardware thing that we had on this stage, so yeah, here.
Yeah, go ahead.
And I have to say that's the lucky winner of the drone. So
okay,
he exists. He's a real person.
This was okay. Thank you. I have just a short question. How do you scale this? Your architecture with the GPU and that into some larger models or larger?
Yeah. Good question. Yeah. So I think I'll focus on the Radeon side of things. In the data center, we have the Instinct series, which has scales very well, and we have now upcoming rec scale solutions, etc. So those are already used for those really large models, like including ChatGPT, Inference. Part of it is run on AMD. But focusing on the consumer graphics products like Radeon, our discrete GPUs support multi-GPU use cases and are optimized for that. So if you have, you can put 2, 4, 8 GPUs, and that's how you get more VRM also while keeping the high performance. So that's the use case that we test for, that we optimize for, and that's officially supported for our Pro cards.
Do you need to do anything on the higher layers?
I mean, yeah, all of those frameworks, most of those frameworks support multi-GPU. So like VLM, PyTorch, they have native support for multi-GPU inference and training. And
yeah, we showed like short videos, but if you want to experiment with Strix Halo, you can go to our booth and try your own prompt there, or like specify something and see what will be the output for image generation. But that device is really great because you have it has 128 gigs of RAM and up to 96, as Filip said, can be used for VRAM, and because of that you can replace 4 regular discrete GPUs. You have a big amount of VRAM, you can load GPT-OSS 120 billion models, billion parameters without any problem. So it's ideal for local experimenting, and you can also combine few of these Strix Halos and try to combine them and run even larger DeepSeek models.
Yeah, and just to add, like in terms of scaling, I think that's the main idea of supporting ROCm on Radeon, because you can really develop locally on the Radeon, then that can be deployed on Instinct without pretty much any changes because it's the same platform. So.